Hey there, awesome physics students. Let's talk about orbits. So what is an orbit? Well, to do that, to talk about it, we're going to do a thought experiment here. We have the Earth here, and we travel to, we climb a very tall tower at the North Pole, and we kick a soccer ball, and we kick it with a velocity like this, and it falls to the Earth, of course. And while it's falling, of course, the only force on it is the force of gravity, and it's in free fall conditions the entire time. Okay, so inspired by this, we concoct a way to launch a soccer ball with much higher speed, and we launch it to another country. Now, of course, it's still, at this point, it's still in free fall. Gravity is the only force acting on it, and still a projectile still crashes into the Earth. But at this point, we notice that the Earth is curved. Instead of here where we just kick it with our foot, the Earth seems flat because it's so small. Inspired by this, we attach a rocket to our leg and kick it with our rocket leg, and it goes at incredibly high velocities. And as it falls, it's still in free fall conditions. Gravity is still the only force acting. Gravity is turning it, causing it to fall, but as it falls, it's falling at the same rate that the Earth is curved. And so as it falls, it keeps missing the Earth, and eventually it comes around and hits you in the back of the head. And that's what's called an orbit. Okay, so an orbit really is no different than an object in free fall. It's just that it has such a large sideways velocity that it's falling at the same rate that the Earth is curved. Or in other words, it's falling, but it keeps missing the Earth because it has such a huge sideways velocity. Okay, so hopefully this helps you understand where orbits come from.